Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic structures in C. What is a structure? Structure is a user-defined data type that allows grouping of variables of different types under a single name. So this is the syntax of a structure. You have the keyword struct. Following struct is the name of the structure, struct name. And inside parenthesis, you have the members of the structure. Each member is defined using its data type member 1, data type member 2, and so on. Structure name, the name used to refer to the structure type. Members, variables of different data types that are part of the structure. Access members, structure members are accessed using the dot operator. Now, why do we need a mechanism or a construct like structure in C? Why do we write programs? We write programs to solve a real world problem, right? The real world problem we are solving has real world objects. So the solution to the real world problem should have real world objects. Structure is a mechanism to support such requirements in the real world application. Now, how do we create objects and how to access the data members of a structure? Let's see with a simple example. Let's consider one simple structure that defines a person. Struct person. Person has name, age, and height. Name is an array of characters. Age is an integer. Height is float. Now the structure person becomes a user-defined data type, and we can create variable of this type. In the function main, variable person1 is created whose data type is person. Struct person1. The structure members can be accessed using the dot operator and initialized as shown. As you can see, the name, age, and height are accessed using the dot operator. String copy function is used to initialize the name of person1 with Albert. Person1.age is assigned 30 and person1.height is assigned 5.9. Now, in a similar way, using the dot operator, we can access the members of a function and display them. So here we are using the printf functions with proper format specifiers to print the members of the structure. So this is one simple example to illustrate how to create a user-defined data type and then create and use a variable of that user-defined data type. To get a more clearer picture, let's consider a few example structures that could be employed in real-world scenarios. So let's first take a student structure. The student structure is for an application that manages student info for a particular institute. A student has a name, age, branch, semester, and subjects. Name is an array of characters, age is float, branch is once again an array of characters, semester is an integer, subjects is an array of characters. So this declares a user-defined data type student, which can be used in a student management application. Now, let's consider one more structure, an EMP structure and an employee structure. This structure is for application that manages employee info for a particular company. An employee has an ID, a name, age, experience, and skills. ID is an integer, name is an array of characters, age is a float, experience is a float, whereas skills once again is an array of characters. So this is a car structure for an application that manages car info for a company that buys and sells cars of different brands. The structure car has the following members: the brand, the model, year, color, price, mileage, fuel type, and is available. Brand is an array of characters. Model is once again an array of characters. Year of manufacturing is an integer. Color of the car is an array of characters. Price of the car is float. Mileage of the car is an integer. Fuel type is an array of characters such as diesel, petrol, etc. The availability is an integer, whether the car is available for a particular brand or model or year or color, etc. So these are some of the structures that can be used in user application softwares. Now let's see some structures used by the system softwares like operating system and compiler. First, let's see a process structure. Operating systems use process structure to manage and keep track of processes in the system. A common data structure for this purpose is the PCB, the process control block. So this is a PCB structure used by the OS to manage the process info. It has the following members: process ID, priority, state, program counter, register values, memory map, and IO status. Process ID is a unique identifier for the process. Priority level of the process. State, the current state of the process, such as ready, running, waiting, etc. Program counter, the address of the next instruction to be executed. Register values, the values of the CPU registers. Memory map, information about memory allocation. IO status, status of IO operations. So these members define a structure called process control block. Similarly, we have file management structure. To manage files, the operating system often uses structures like the file control block or the inode in Unix file systems. The inode structure contains information about a file. This is the inode structure used by the operating system to manage file info. The inode structure has the following members: inode, unique ID for file within the file system. This is an integer. File size, size of the file in bytes, once again an integer. Block pointers, pointers to the data blocks where the file contents are stored, an integer. Permissions, access control information such as read, write, execute, etc., an integer. Owner ID, user ID of the file owner, once again an integer. Group ID of the file owner, once again an integer. Creation time, the timestamp when the file was created, an integer. Modification time, timestamp of the last modification. Access time, timestamp of the last access. All these data members are integers. So this is about the inode structure used by the operating system. Now let's see one structure used by a compiler. Compiler uses symbol table to manage information about identifiers like variables, functions, etc. in the source code. A typical symbol table entry might look like this. So the symbol entry is used to manage symbol information. It has following members: name, the name of the identifier, an array of characters. Scope level, the level of scope, local, global, etc. Data type, the type of the symbol, integer, float, etc. Address, the memory address or the offset in the symbol table, which is an integer again. Size of the symbol in bytes. So this represents a symbol which is used by the compiler to manage the source code. Now let's try to use one of this structure in our program. We'll try to use a student structure and implement a student management system. A student management system to manage students in an institute. It maintains a database of students and enables administrator to access the student information. You already have a student structure that can memorize following details: the name, age, branch, semester, and subjects. Let's assume there are around 500 students in the institute at different branches and semesters. Some of the operations that could be performed on this list of students is finding a student in the list of students by name, listing the students of a particular branch, or listing the students of a particular semester of a particular branch. So let's see the prototype of these three types of functions. Find student by name. What do we need here? We need the name of the student to search in the list. The student list is needed, and the number of elements in the student list is needed. List students in branch. Here we need the student list, the number of elements in the list, and the branch. And finally, list students in semester branch. This needs a student list, number of elements in the student list, the branch, and the semester. Let's write the main program. In this program, instead of fetching the student data from the database or files, we are receiving it from the input device. We can always modify to include a database or a file system access. Here, we are entering the number of students. Then we are declaring a student list using that number. Then we run the loop that many number of times, that is n number of times, and initialize information for n students. We are getting details of one student at a time. The student's name, age, branch, semester, and subjects are received from the user and loaded into the members of the structures. Then, at the end of the loop, this list will have the details of all the students. Now, to find a student by name, we can ask the user to enter the name of the student who needs to be searched in the list. Once you enter the name, you can invoke the function find student by name, pass the student list students and the number of elements in the students, and name to find. Similarly, branch to find, we are assuming it is computer science CS. Then we are passing branch to find to list students in branch function. Similarly, semester to find, we are initializing it to 4 to list the students in 4th semester and branch CS. We are passing students and branch to find and sem to find to the function list students in sem branch. This is how the function looks. The find student by name function. It has 3 parameters: student list, the number of students, and the name to be searched. We loop through the entire list and try to compare the given name with the name of the student. If it matches, we print the details of that student and returns. If the entire loop executes and there is no match, then an error is displayed. Student with particular name is not found. List students in branch. Similarly, in place of name, we are searching the branch and the logic remains the same. Here, branch always exists and we don't return for the first occurrence of the branch because we want all the students of that branch to be displayed. So every time the branch matches with the branch of the student, the details of that student is displayed. So the list students in semester branch is implemented the same way. If the branch and the student semester match, branch is compared using a string compare function, whereas semester is an integer which could be compared using a equality operator directly. If the branch and the semester which we are searching matches with that of the student, we'll display the details of that student and then return. So this is a simple implementation of a student management system. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.